All right, so I'm gonna start with number 3 this time on, what are we looking at? 1.4, 1.5, the first assignment, and work through a few of these problems. So hopefully this will be helpful if you have any questions on this. Remember, there's also a key if you don't want to listen to my voice. So, okay, so the graph at right shows the relationship between the age of a grapefruit tree. Okay, here's the age, the y-axis, and the diameter of its trunk diameter. Let A of D be the age of a grapefruit tree whose diameter is D inches. So it looks like we are plugging in the diameter and getting out the age. Kind of interesting. Normally, I feel like you'd plug in the age and get out the diameter, but you know what? I'm an adult, so I do what I want as long as it doesn't harm anyone else. In fact, maybe as long as it is beneficial to another person. But anyways, it's another story. So explain why it only makes sense for this relation to be a function in terms of what it represents. Ah, what an interesting question. Okay, well, what I think about this is what we're plugging in is the diameter. So trees are always growing, even if slowly. So every diameter must correspond to exactly 1 year. Unless it's possible for a tree to shrink, or stop growing, but I think it's always growing. So that's why I would say this is definitely a function. Each diameter has to correspond to only 1 year. Definitely looks so on the graph, passes the vertical line test. Estimate the range and write your answer using set builder notation. Well, the range is the y value, so that's going to be this distance right here. So it looks like the lowest value is maybe 1, and the highest value is maybe 23. So I'm going to say that it is A such that 1 is less than or equal to A is less than or equal to 24. So we're looking at trees that are between the ages of 1 and 24 years old. Estimate A of 10 from the graph. Well, here's 10, and I want to find A of 10. So that should be right here, right? I find 10, and then I move up. And that looks like it is about 17. So I'm going to say that A of 10 is equal to 17 years. What diameters correspond to a tree aged between 10 and 20 years? Okay, well, a tree aged between 10 and 20 years, so here's 10 and here's 20. And so if I come over to the graph over here, that's this point here and this point here. So now I need to find the trunk diameters that correspond to that. And it looks like to me that that's between about 7 and 12. So we'd say D such that 7 is less than or equal to D, which is less than or equal to 12. So those are the diameters that correspond to those ages. Okay, that's clear, and scroll down. Suppose we had another function B of D that gave the age of an orange tree. If this graph were less steep, what would this tell you about the orange tree in comparison to the grapefruit tree? So we're imagining, and I like to draw this out because this is a complex question here, but we're imagining that we have an orange tree that is less steep. The graph is less steep. So what I can see is as the diameters increase here, the age is going up more slowly for the blue one, right? So it basically means that less time is passing as the diameters get bigger. So diameters are getting bigger, less time. So that means the orange tree is growing faster. Orange tree grows faster. Now that's a little bit weird because normally when we think of something being less steep, we think slower, and that makes sense. But because of what the input and the output are here, actually what's happening is that the diameters are increasing less quickly with respect to age, but really what that means is, look here, this thing has reached 15-inch diameter in only 12 years. And this one, it took 24 years. So it's actually growing twice as fast, which is kind of an interesting thing there. Okay, let's look at this one. So n is the number of sides of a polygon. F of n is the number of its diagonals. The figures at the right show that f of 4 equals 2 and f of 5 equals 5. Find f of 3 and f of 6. So again, it's really, really important to find inputs and outputs. So n is the input, and that's the number of sides. And f of n is the output, and that is giving us the number of diagonals. So if I want to find f of 3, I need to draw a triangle because that has 3 sides. 1, 2, 3. How many diagonals does it have? None. Right? Because I can't draw a diagonal in between these. There just are none. 6. 1, 2, 3, 4, 5, 6 sides. And here's 1 diagonal, 2 diagonals, 3 diagonals, 4, 5, 6, 7, 8. Did I get them all? 1, 2, there should be 2. 1, 2, 3. I think I got them all, but my drawing's not great. No, there's one more there. There it is. So there should be 9. So f of 6 equals 9. Okay, so if in doubt, draw it out. Just draw it out always is what I would do. Okay, great. Okay, so last problem is, actually it's not, but we've got 5 and we've got 6. So let's look at 5 first. So P of t and M of t. Maria and Pia traveled during a 40-kilometer bike race. Estimate P of 0.5 minus P of M of 0.5. What does this quantity represent? So that is looking like we are looking at this zone right here, right? Because here's 0.5. Here's P of 0.5 and M of 0.5. So it looks like P of 0.5, oh no, sorry, P is the red one. So P of 0.5 looks like it's about 11, and M of 0.5 looks like it's about 8. You might have estimated differently, that's okay. But this looks like it's gonna give us 8, 9, 10, that's gonna give us 3, and the units of y, this distance, is kilometers. And so thinking about what that might mean, this means that after 0.5 hours, Pia is 3 kilometers ahead of Maria, right? Because they have gone 3 kilometers further. Okay, find a non-zero value of t such that P of t equals M of t. So we're looking for where these things cross. Obviously they started at the same place, but we also see that they crossed paths here at t equals 1. So t equals 1. And what's happening? Well, it looks like Maria is passing Pia, right? Maria started out behind Pia, but then whoop, passed Pia right there and actually ended the race a little bit sooner. And that relates to the question down here, right? I'll clear these again. The question right here, which is, do P of t and M of t have the same domain? Why or why not? What about range? Okay, so domain is going to be this. Let's see if my tablet's going to work here. But domain is this distance here. So it looks like Maria finished the race in 1.75 hours while it took Pia 2. So no, they do not have the same domain because Maria finished sooner than Pia. It took her less time. So I would say, nope. Maria finished before Pia. Do they have the same range? But the range, yep, because they both did the same race, right? So, we can see that the range, their top and bottom values are actually the same. Okay. Okay, so we've got a function g of x, and we're asked to find g of -3, g of -2, g of 0, g of 2, and g of 3. So let's go ahead and do that. So let's see here, g of -3. Let's plug -3 into this little function machine and see what we get. We've got -3 squared plus 8 times -2. I didn't really say that in the right way, but I think you know what I mean. So -3 squared is like 17. Now it's 9. So that would be -18 plus 8, which is -10. G of -2, hopefully you're going to find on your own if you haven't already. So you can pause this, is -2 times -2 squared plus 8. And that is 4 times -2, -8 plus 8, which is 0. G of 0 is just going to be 8 because this part will disappear. And G of 2 is actually also going to be 0. And G of 3 is also going to be -10. You can check my work on that, but I think that's true. So let's plot these points. Remember that G of -3 equaling -10 is the point -3, -10. And G of -2 equaling 0 is the point -2, 0. And this is the point 0, 8. And this is the point 3, -10. And this is the point 2, 0. Okay, so -3, -10 is right here. -2, 0 is right there. 0, 8 is right there. 2, 0 is here, and 3, -10 is here. And so if we sketch this function, it should look like that, right? So that is a parabola. And that's what we expect from an x squared function. Okay, so let's scroll down. I'll leave my work there for now. Okay, it says, let's see here, what can I erase? Maybe I can get rid of all these points and just keep the graph. But it basically says, what symmetry do you see? So it looks like to me that it's symmetric across the y-axis. It's reflected across the y-axis, meaning that it's the same on one side. If you reflect it over, it will be the same. So I'm going to put that it's symmetric across the y-axis. What is the y-intercept of the graph? Well, the y-intercept of the graph was 0, 8. That was the point that we got out. Explain why it's not possible for a function to have multiple y-intercepts. Well, if you had two y-intercepts, so let's say that you had another y-intercept that was down here, then all of a sudden you are failing the vertical line test. And that basically means that it wouldn't be a function because in that case, x equals 0 would have more than one output. That's not a function, right? You can't plug in 0 and get out two different things, then it wouldn't be a function. The x-intercepts of these graphs, I'm going to go ahead and erase some things here. So let's erase this. But the x-intercepts were, let's see here, they were -2, 0, whoops, and 2, 0. So those were the x-intercepts. Explain why it's possible for a function to have multiple x-intercepts. Okay, so I like to say that while you can't go to two parties at the same time, right? It's okay if two people go to the same party. So it's fine if -2 goes to the 0 party and 2 goes to the 0 party. The problem would be if you tried to send 2 to multiple places. Okay, And finally, scrolling down here, I think we're getting close. We just need to think about this. The scales of the axes for the coordinate plane are not the same. Okay, so let's look up here. Here, you know, we're counting by 5s, and here we're counting by 1s. So basically we've squashed in the y-axis to be able to plot points. So how would the graph look different, or maybe differently would be the way to say it, if the scales were the same? Why might it be important to take note of the scale on a graph? So basically, if it were the same, it would stretch everything up. And so the graph would look a lot steeper and narrower, right? And so I think I'm just going to say this, but we could think about, well, we are trying to interpret things. And so if a graph looks really not steep, you know, like if we squash the y-axis way down on the growth of coronavirus cases, we might think, oh, there's not that many, it's fine. But we need to be thinking carefully about that scale to say, oh, there are a lot of coronavirus cases coming out. So we better social distance, right? So that would be one example of why that taking note of the scale would be really important. So I think that does it for this assignment. So I'll call it right there. Okay. Hope that was fun. I had a good time.